So good morning, everybody. Welcome to Math 096. Like I said earlier, there are 4 different documents on the table, so go ahead and grab one of each. We'll go through each of them in turn, but for right now, I want to start with the biggest document, this massive packet that you'll find on the table. And it looks like this at the top, lesson number 1. And we're going to jump right into doing some math here in number 3. With a quick note, unless noted otherwise, the problems in the class packet are intended to be done without a calculator, so put those calculators away. I will give you special instructions on the rare times when I want you to use the calculator. What do you need? Big packet is, let's see, let's grab one from another table. Can we grab one there? Thank you. Okay. So we're going to start here. Consider the equation y equals x plus 4. Part A says fill in the table with 4 solutions to this equation. First row has been done already. So the table has a column for x's, a column for y's, and then a column for the ordered pair xy together. In the first column, I've just picked some arbitrary x's, so you don't have any choice there. If x is -5, we're going to plug -5 right in here for this x, and we get y equals -5 plus 4, which is written there, and that's -1. And so apparently when x is -5, how much is y? Y is -1 ultimately, right? And so then the point -5 comma -1 goes in parentheses. Can you guys take a moment to fill in the other 3 rows of that table, and then we'll come back together. Okay, and if you've gotten to the place where you've filled in your table, next thing you're going to do is plot 4 points. The first one has already been plotted for you, -5, -1. So finish up your table, then plot the other 3 points. And then you're going to use a straight edge if you can to connect the dots. Okay, so once you've got your line drawn there, I'll first point out, technically lines go how far? Forever. And at some point in my schooling, I got points off because I didn't put arrows on both ends. I will not take points off, but make sure that you do not do the following because you will lose points. If you draw that line, I'm going to say, well, that's kind of, I don't know if arrogant is the right word, but the line doesn't care what points you picked, right? And to start and stop it at the points that we picked just seems like very, it's like self-centered or something. The line goes forever. So just make sure that you extend your line to the edges of the graph paper. That's good enough for my purposes. And then last question as we review stuff here with lines. It says, which quadrants does this line pass through? So first we have to refresh our memory about the numbers for the quadrants. Which one is quadrant 1? On the right top. Okay, so that's a 1, and we typically use Roman numerals for the quadrants. And where's 2? Is it bottom right? Yeah. Everybody says quadrant 2 is down here. Somebody says up here. Anybody else say up here? Okay, so for some reason, we go counterclockwise when we label the quadrants. I don't know why we do that, but we do. And then down here, bottom left is quadrant 3, and then bottom right is quadrant 4, IV. So which quadrants does this line pass through? 1, 2, and 3. That's it. Okay, so that was just a quick review of stuff with lines. And we'll go on to the next page and solve one equation in 2 different ways. And this one, the steps are actually already written out. We're just going to do some kind of pointing here. You'll get plenty of practice solving equations today. So for right here, we're just going to point to the steps. So here's the equation. 1/2 x equals 5/3 times the quantity x minus 65. Couple of choices. First way is maybe the natural way. Second way is a lot easier, so I'm hoping to convince you to try the second way if you have a chance. But the first thing to maybe try is to, what's it called when you take that 5/3 and multiply by everybody in the parentheses? Distribute. So that's the first thing that a lot of people think, and that's totally fine to do. So we're going to distribute that 5/3 into the parentheses, multiply it by the x and by the 65. So that gets us to here, 5/3 x minus 325 over 3. You'll have to take my word for it, but 5/3 times 65 turns out to be 325 over 3. With time, you could do that on your own, right? Next thing I see is that there are x's on both sides of the equation. The way to fix that is to make it so that all the x's get to one side of the equation. So I'll choose to take this 5/3 x and subtract it from both sides to move it to the left. And that gets me right here. Now I'm going to combine those two like terms. It's some x's minus some other x's. Now don't get distracted by the fact that there are fractions. If I gave you 7x minus 5x, you would have no problem telling me, oh, that's easy, right? That's 2x. It's the same idea, it's just not 7 and 5, it's a half and 5/3. So apparently what we're supposed to do is a half minus 5/3, just like you did 7 minus 5 for the easier example. Okay, half minus 5/3, how do you subtract fractions? Common denominator. So you can see this is pretty involved. But anyway, you find the common denominator. It turns out, I'm going to put a ... because we're hiding some of the steps here. But it turns out when you smush those things together, you get -7/6. You can check that later on too. So ultimately we get down to here, -7/6x equals -325 over 3. Still pretty messy. And then the last step is to get rid of this -7 over 6 because it's touching the x and I want everything away from the x. So how do I move that fraction to the other side? Divide both sides by, yes, divide both sides by -7/6. It will definitely move from the left side to the right side. So that is exactly the right thing to do. I'm going to write it and then I'm going to erase it. Dividing by -7/6 is kind of a messy thing to be left with because now we have a fraction over a fraction, and you may or may not remember how to handle that kind of thing. We're going to do something that's maybe slightly more efficient than that, but it accomplishes exactly the same thing. Instead of dividing by -7/6, we're going to multiply by -6 over 7. Whatever you do on one side, you better do on the other. Balance the scales. By the way, what's the fancy math word for flipping a fraction? Reciprocal. So we multiplied by the reciprocal. How come? Let's see. The 6 here cancels the 6 there. And the 7 there cancels the 7 there, and then negative times negative is a positive. We saw that earlier today. So the -7/6 just disappears, which was the whole idea, right? So multiplying something by its reciprocal makes it cancel out to just a 1. Super. So last thing we need to do then is multiply here. How do you multiply fractions? Common denominator or no? No, we just go straight across. So 325 times 6, 650. Let's see, apparently that's not right. This has already been reduced, but maybe before we go straight across, we could cancel the 6 and the 3 and make it a 2 and a 1, and then straight across. Whew. Only the first day, but I'm already winded. Okay. I changed the 6 and the 3. I reduced the 6 over 3 to a 2 over 1. Right. Yeah, and then I multiplied the 2 times the 325. Then multiply across. No, it's easier. You could multiply first and then reduce at the end. Right. It's always easier to reduce first and then multiply at the end. Okay, I said there was a better way, so let's take a look at the better way. Instead of distributing that 5/3, which is legal but not required, we're going to multiply both sides by some magical number that's going to get rid of all the fractions. So looking at the denominators, there's a 2 and a 3. What's the lowest common denominator for a 2 and a 3? It's a 6. And what we're going to do is multiply both sides by 6. Might not be clear why we're doing that, but at least as long as we do the same thing on both sides, it's legitimate, it's legal. So here it is in the next line. Just multiply both sides by 6. Everything else has been copied. So what happens here? 6, if you really want to see it as a fraction, make it look like 6 over 1. And then 6 and 2 reduce and become 3. And then 6 and 3 reduce and become 2. And what just happened? What disappeared? The fractions. And so every equation from this point forward is going to be free of fractions until the very last step. Wonderful. So the left-hand side is just 3 times 1 times x, so that's just 3x. On the right-hand side, I've got 2 times 5 is just 10. Now, there is a risk here. This is correct, 10 parentheses x minus 65. The risk is a very common mistake, and that's folks taking the 2 and multiplying it by the 5. Great. But also taking the 2 and bringing it into the parentheses. Not great. If you had something like this, 2 times 3 times 4, does that 2 hit both? No, right? This is just multiplication, and you can multiply in any order you want, but there's no distributing here, right? The fact that I put this guy in parentheses, and the fact that maybe it's just a little bit more complicated than a single number 4 doesn't change that it's one multiplication. And this 2 times 3 times something in parentheses is exactly what we are looking at here. 2 times 5 times something in parentheses. It is just one multiplication problem, and as soon as you move that 2 into the 5, the 2 has been taken care of. It doesn't go anywhere else. Okay, and then from here on out, it's pretty easy. Distribute the 10, get a 10x minus 650. Again, x is on both sides, so let's move them all to one side. Subtract the 10x gives you negative 7x, and then divide by negative 7. Okay? All right. Let's take a look at some of the logistical stuff we have to do. So we'll start by looking at the syllabus, and then we'll come back to this big packet here. So part of your homework tonight is going to be to read through this syllabus and ask me any questions that you might have. We're going to spend very little time together looking at the syllabus. My contact info is at the top there. My office hours are listed, but I have lots more availability besides the times that are listed there. So just contact me and we will find a time to meet. I want to spend a minute talking about the required materials for this course. We're going to use something called My Math Lab for this course. Show of hands if you used My Math Lab before. Just a couple. My Math Lab is a piece of paid software, and it is going to be where you find the textbook, and it is going to be where you do the homework and find lots of other resources like videos and practice problems and things like that. There are going to be instructions on this other document here at the top. It says how to register for My Math Lab. So make sure you can find that. So this is going to be real important for you tonight to follow the process laid out in this other packet about how to register for My Math Lab. I will say that, does anybody happen to know how much a My Math Lab code costs right now? About 100? That was about what I thought it would be. It is in lieu of a textbook, so it's not $100 plus go out and buy another $100 textbook. It is the textbook and a whole lot more. If you are working on getting funding together, I still want you to go through this process tonight if at all possible. You can sign up for a 14-day free trial and hopefully funding comes in within those 14 days. You can buy the My Math Lab course directly through Pearson for a little bit less money than it costs you if you go through the GCC bookstore. But if you use the GCC bookstore, you can use financial aid to pay for it. You can figure that out, but explore your options, okay? But whatever you decide, I'm hoping that people can get signed up even with that 14-day free trial tonight so we can get just right away started on doing the homework. If you already have a My Math Lab course from taking this course in a previous semester, you do not need to pay for another one. Just come find me right after class and I'll tell you how to use the access code that you've already purchased. The other thing I want to look at on this document right here is on the last page. So go ahead and jump to the back of the last page. And you'll see a grid, which looks an awful lot like this grid that's up here. So there's a lot of information in the grid. I just want to point to two things right now. First of all, in this class, we have in-class assessments that are tests. We have a couple of those, and then we have in-class assessments that are quests. The word quest is kind of a hybrid of quiz and test. It's sort of bigger than a quiz, not as big as a test. Our first quest is coming up on February the 10th, so we've still got some time before that happens, but just putting it out there that you got the exact dates when we're going to have all of our quests and tests and even the final exam, assuming we don't have snow days between now and then. The other thing I want to say about this document is that it tells you when the homework is assigned and when the homework is due. And our rule of thumb is that there's going to be homework assigned almost every class. and it will almost always be due the very next class. So for example, the homework assigned on February 1st will be due on the 3rd. The homework assigned on February 3rd will be due on the 5th. It's just always the next class at the start of class, like 8:40 a.m. is when I have set up my math lab to say this homework is due by such and such a time. If you turn the homework in later than that, there is a 10% penalty, but you can turn it in as late as you wish. And let's say there are 8 homework problems and you do 7 of them on time and 1 of them is late, the 10% penalty only applies to the one that's late, right? So even if you can't finish the whole assignment on time, get as many as you can done before it's due, and the 10% penalty only kicks in on the ones that are actually late. One exception to this homework due the next class policy is here in the first couple of classes. January 27 is today, Friday is the 29th, but I'm making these homeworks due on February 3rd, which is definitely not next class. It's Wednesday of next week, because I know that there are always people that have some little technical glitches. And so I just want to give folks a week to really make sure that they can sign into my math lab. And if their computer at home is having any kind of issues, then we don't have any penalties coming in right at the beginning, okay? You will have lots of questions for me about my math lab, but it makes sense to just try to dive right in, and then we can talk about any issues that come up, all right? Okay, so the only other handout that we haven't talked about is the one-page key prerequisite skills. I'm just gonna say that this is part of your homework, but it will be referenced in tonight's homework assignment, which I'll show you later. But it's not going to be collected, and we're not going over it in class. But the basic idea here is if you have some deficits, you need to let me know right away. If you get to some section of problems that is particularly tricky, then let me know as soon as you can, and I'll give you some resources to get you caught up. And we're going to make sure that you're here in the right spot, okay? So that's really just for your own self-assessment. All right, and then the last thing I wanted to take a look at before we jump back into the math is the math flowchart. So here it is. So this is a list of all of the math classes that we offer here at GCC. And I will say that right now we are here in Math 096. And I will say that some of you are here in this course because you need another math class down the line, something below Math 096, for example, the stats class or the college algebra class or anything farther down, and that's great. Some of you are here because of a nursing requirement or a biology requirement. And so if you are one of those folks who is here because you've got to be here for some prerequisite thing, then that's great. You can tune me out for the next 60 seconds. But if you are here only because you are trying to get the math requirement, the liberal arts core requirement for one of our liberal arts associate's degrees, I will tell you that, first of all, this course will not get you that requirement. This is technically called a developmental course. The 0 in the front tells you that. And that almost all of you, and perhaps all of you at this particular moment, this semester, could take Math 117 instead of the course that you're in now. And Math 117 does count towards that liberal arts math requirement. So again, if you're here because you need prereqs for some other class, or you're here because you got to get further down the math chain, great, stay exactly right here. But if your intention in taking math is simply to fulfill the math requirement of a liberal arts degree, this might not be the most appropriate course for you, in that after you take this one, you still need one more math class. But instead of this one, you could take another math class right now instead of this one this semester and be done with that math requirement.
So if I went 95 and I'm going 6, I gotta go 17. I mean, 1.
Yes.
Should I try to?
No, you can't get to 114 without going through here.
Oh.
Yeah, so if you're below us, if you're below this class on the tree, then you got to go through 096. What I'm saying is that 117 is on the same level as our course, and you don't need 096 to take 117. All right, so if you think that what I just said might apply to you, see me right after class, and let's make sure, again, that you're in the right spot. All right, it is not too late to switch you to another class that would fulfill the math requirement and be done with it this semester. Okay. All right, so, going back to the big packet, and we finished this page, we're going to move on to the next page. And we'll give you just a brief discussion about the structure of our course. Typically, the first, say, 15 minutes or so, it's going to be the demo. It's the part where I lead us, which is exactly what we did there with the drawing the line and the solving the two equations. The vast majority of the course is going to be activities, and it's going to be you guys working with your neighbors on problems, and I'm just going to walk around and help. And so that's what we're about to do right here. And we'll just read this note real quick. Working and struggling through the activities on your own or with your table mates will increase your understanding of algebra immensely. An answer key usually follows the activities, but check your answers with your neighbors before checking with the answer key. If you get stuck, raise a flag. But I think it's really important to talk about math, and it's not super important that we all get exactly the same answer at exactly the same moment. It's more important to talk about math and talk about some of the errors that pop up. I like errors popping up now. It gives us a chance to figure out why they come up before it counts, like before on a test or a quest, okay? So you're about to work through these activities with your neighbors, but before we do, why don't you spend 20 seconds or write down the names of everybody at your table and then jump into these equations. Okay, so we're given the graph of this crazy complicated equation, y equals a whole lot of stuff. That crazy complicated equation is graphed in this diagonal line. And then we're asked to solve this crazy complicated equation here, 5 equals a whole bunch of stuff. And the first observation is that all of this is exactly the same as all of this. You can check it term for term. They're copied. I can tell you they're copied because I literally copied and pasted. So that means the only difference between these two equations is that the y has become 5. Yes? So solving that equation means look at the diagonal line that's graphed and tell me what's going on at the point where y is 5. So let's go to the graph. We're going to find the spots where y is equal to 5. So y equals 5 is here, but we need a spot on the diagonal line where y is 5. So it turns out there's lots of places where y is 5, yes? For example, those are 2 other points where the y is definitely 5. We want to go to the one spot on the diagonal line where the y is 5. So I like to represent this graphically with a little arrow. Find y equals 5 on the y-axis, and then I go either left or right until I find the diagonal line. The equation in part A has only what letter in it? X. The equation ultimately is asking for an X. Well, I've got a point, and I'm asking for an X. And so where do I look to estimate the X? Straight down. And so you come down here and you ballpark your number. And we'll say about negative 2.8 or negative 2.7. Make sure you follow the directions here for this question. It says make sure your answer is of the form x equals some number. Okay? So once you know how to do these problems, they become very easy, easier than any of the equations you solved today. Okay? So why don't you take 60 seconds, see if you can zip through B, C, and D, and then we'll come back together one last time to talk about the homework assignment. Okay, so again, a reminder of the basic structure of this packet, the structure of the time we spend together. There's the brief demo at the start of class where we all work on the same thing, me up here, you there. Bulk of the class is on the activity. That's what we did here together, working with our neighbors. The next section, it's on the very next page after the graph that we just looked at, is called Even More Practice. The even more practice problems are there for folks who are able to speed through the activities and finish them in class. That's wonderful, but not going to happen all that often. But if it happens, I want to give those folks something to do. And it's also for people who just want more practice and feel like they didn't get enough practice with the problems in class. There it is. These problems are optional. These are the only problems in the entire packet that are optional. Every other problem in this packet I'm expecting you to do, even if that means working on it outside of class. I know that most of the groups didn't quite finish those equations, the second page of equations, but I want you to finish them as part of your homework. I'm not going to collect it, but my expectation is you're doing every problem in here, most of them in class, but some of them out of class, except for the even more practice. All right? Even more practice continues, and you'll see lots of stuff that looks familiar. I have also included an answer key to the even more practice, so there's always answer keys to these problems in the packet. And on the next page, so let's jump there now, we see this thing that says learning objectives after lesson number 1. So the first thing in this list is a list of things that I expect you will be able to do after you have studied and after you've done homework and practiced with all of this. It's a list of skills. I want you to know how to solve equations using the principles of equality, like adding 5 to both sides. The fact that 5 is equal to 5 allows us to do that. I want you to be able to handle equations with fractions in them. I want you to be able to do a whole lot of stuff. This is my concrete list of the things I want you to do after you have finished working on all the things from this particular course. There is a reading assignment. It is sections 1.3 and 1.4. The textbook is something that is online. When you purchase that access code through My Math Lab, you have access to the complete textbook. And inside of that textbook, you will find these 2 sections, and you read through them. They should solidify the stuff that you did in class together. You're going to read the entire syllabus, and you're going to write down any questions that you have for me. The homework assignment will always start with finish the activities. Again, assuming that some of you will finish in class, but most will have a little bit to do outside of class. In this case, you get a little bit more stuff to do just because it's the first class of the semester. You're going to register for My Math Lab. Again, go ahead and sign up for that 14-day free trial, even as you figure out where you're going to get that access code. And you can do that free trial whether you buy the access code directly from the publisher or through our bookstore. Doesn't make any difference how you get the access code ultimately. What's that? About $100 is what we've heard. It varies depending on whether you buy it at the bookstore or through the publisher. Oh, so maybe there's quite a bit more at the bookstore. Mm-hmm. Yeah, so shop around a little bit. But regardless of the shopping around, do the free trial so you can get into the swing of things. Okay, once you log into My Math Lab, and this will make more sense once you're actually there, you're going to do the homework assignment labeled homework after lesson number 1. It's not a very imaginative label, but it's going to be an easy way to figure out exactly what homework you're supposed to do. This was lesson 1. That's the name of the assignment. There's also a lesson 0 assignment. It is completely optional, but it's just like a primer on how to use My Math Lab and the interface, and it's just walking you through the steps. So it might be worth your time, especially if you have a little bit of hesitancy using computer stuff. Okay, and then finally, just tell me a little bit about yourself. This will be like the only time during the semester I ask you to write things down that aren't math, but I want to get to know you guys. So tell me a little bit about yourself, and you can give that to me next time, okay? All right, good work today. We'll see you on Friday.